Welcome back. In this session, you give the first example on how to solve a second order differential equation using method of Laplace transforms. So let's see the equation. So the problem is to solve the initial value problem. Y double prime minus y equals to minus t squared. The initial conditions are y at 0 is 2, derivative of y at 0 is 0, using the method of Laplace transform. So let's discuss the solution to this problem. So the first thing, we take Laplace transform on both sides of the differential equation. So I will write Laplace transform of y prime minus Laplace transform of y equals to Laplace transform of minus t squared. That is usually the first step. And then the second step, we know that given Laplace transform of y is capital Y of s, then the Laplace transform of y double prime is given by s squared capital Y of s minus s y at 0 minus derivative of y at 0. This by definition. So we replace this one as, so if we call this one equation 1, then 1 becomes, so instead of writing this Laplace of y double prime, we write this s squared capital Y of s minus s y at 0 minus y prime at 0, and then minus Laplace transform of y is taken as capital Y of s. It's given by, now using Laplace transform tables, you can find the value of Laplace transform of minus t squared, or you can just directly work out the value of this, the Laplace transform of minus t squared, and your answer should be minus 2 over s power 3. So which means that replacing in the values given, remember that y at 0 was given as 2, so we'll have s squared capital Y of s minus, so this is 2, so 2 times s will be 2s minus this y prime at 0 in the equation was given as 0 minus capital Y of s equals to minus 2 over s power 3. So collecting terms with capital Y of s, we'll have s squared minus 1, and then capital Y of s is equals to, then this will go to the right hand side, will be plus, so 2s minus 2 over s power 3. This we can write this one as, this is like over 1 s power 3, 2 s power 4 minus 2. So that we write this one as s squared minus 1 capital Y of s is given by, so you can factor out to write 2 into s power 4 minus 1 divided by s power 3. Now you can write this one. So remember, this is s power 4 can be written as s squared square, and then we can write 1 as square. So we can write this one as 2 into s squared minus 1 times s squared plus 1. This is a difference of two squares. You divide this one by s power 3. So which implies that capital Y of s, now you'll divide through by this bracket, will be 2 into s squared minus 1 times s squared plus 1. You divide this one by s squared minus 1. And then there's an s power 3 at this point here. So clearly you see that one of the brackets will cancel out. So this and this cancels out. So this will give us 2 s squared plus 1 over s power 3. This is what we have. Now you write this one as capital Y of s is given by, now this is the same as 2s squared plus 2 divided by s power 3, which you can write it as, so dividing every term by s power 3 will be 2 over s and then plus 2 over s power 3. So if I call this one equation 2, then taking the inverse Laplace transform on both sides of 2, we get, so inverse Laplace transform of capital Y of s is inverse Laplace transform of 2 over s plus inverse Laplace transform of 2 over s cubed. And so using the Laplace transform tables, you should be able to find, so this now inverse Laplace of capital Y will be now Y of t. This will give us 2, because this can as well be written as twice inverse Laplace transform of 1 over s, whose function is 1, and then plus, this is just the standard Laplace transform, 2 over s cubed. So it will be 2 plus t power 2. So that becomes the solution to that given equation. So therefore, the solution for the initial value problem is y of t is given by 2 plus t squared. So that's how we work out that problem. Thank you.